Take a tour of the nighttime sky as we go in search of the planets and constellations on Amazing Space, continuing next from TLC.
The ancients found their fates etched in the heavens. Today's stargazer can follow the explosive lives and deaths of the stars themselves. Join us on a tour of the night sky. Next on Amazing Space. The sun shines on our rotating planet, its reflection skimming across the Pacific in this amazing sequence from space. It's this spin that creates the illusion of the sun's path across our skies. Earth's rotation also makes the stars turn gently above us each night. The combined spin of Earth and its annual orbit of the sun means that our view of the sun's position against the stars shifts by 4 minutes every day. As the seasons change, the sun traces a path through the background stars, a path called the ecliptic. Ancient astrologers strung figures along the line, forms suggested by groups of stars called constellations. The constellations of the ecliptic form what's called the zodiac. Long ago, but the constellations retain their mythical names. An unfocused photograph of stars reveals what our eyes cannot perceive. We see them this way, minus the subtleties of starlight. The stars have distinct colors, as an astronomical photograph or the view through binoculars will show. Good binoculars are the first essential for a new observer. Marked on every pair are numbers specifying magnification and lens size. These 10 times 50. The 10 indicates that this pair will magnify the image by a power of 10. The 50 is the size of the lenses, 50 millimeters. Here the eyepieces are marked 5 millimeters. That's the width of the light beam entering your eyes. The size you need depends on your age. If you're under 40, the pupils of your eyes will dilate to 7 millimeters. If you're over 40, they'll dilate less, just 5 millimeters. The more serious amateur observer may want to invest in a telescope with the help of a reputable telescope shop. This is a typical beginner's telescope, a refractor. For stability, it's mounted on a stand. A refractor gathers starlight through a large lens. The image is focused at the other end of the tube and magnified in the eyepiece. The amount of light gathered is what's important, not magnification. An alternative starter is this reflecting telescope. Again, it's the capacity to gather light that matters. Incoming light hits a mirror at the bottom of the tube. The light is bounced to a smaller mirror and reflected to an eyepiece on the side. A manual drive is a handy accessory for keeping a telescope on track, compensating for Earth's rotation. For a bigger telescope, you need a motor drive. Greater magnification needs finer tracking. When you begin your stargazing from the northern hemisphere, you'll want to start where Earth's axis points, northward towards Polaris, the pole star. From wherever you stand on Earth, only half the sky is visible. So Polaris appears lower and lower in the sky the further south you go. If you're at the equator, Polaris sits on the horizon. In the southern hemisphere, Polaris disappears altogether. Starting from Singapore, the south pole of the sky gets higher and higher the further south you travel. These are the stars of the southern skies, circling the south pole of the sky. Here, their northern counterparts, in long exposure. The Big Dipper is the place to start your survey of the northern sky. Ursa Major, the Great Bear. The two stars at the edge of the Dipper will point you to the pole star Polaris. Polaris is an Ursa Minor, also called the Little Dipper or Little Bear. A line through Polaris from the second star in the handle of the Big Dipper leads to the W of Cassiopeia. These two, forming the top of the Dipper, point to the star Capella, a brilliant point in the constellation of Auriga. This side of the Dipper points to another important star, Regulus. Regulus is in Leo the Lion. Finally, extend the handle of the Big Dipper around to Arcturus, a red giant star in Bootes, the herdsman, and then on to brilliant Spica. The first leg of your journey through the heavens.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
The glory of the Milky Way, our perspective and profile of the galaxy in which we live. An astronomical vista best observed when it's summer in the northern hemisphere and winter in the south. When our most powerful telescopes peer into clouds of gas and dust and the heart of our galaxy. They look fixed to us, but most stars are in motion around that galactic heart. But in the span of a human lifetime, they won't seem to move at all. The 200 billion stars of the Milky Way are all gently turning. One of them, our sun, takes 200 million years to orbit the galactic center. If we could fast forward 10,000 years, the stars would reposition this way. As we look into the night sky, it's the point in Earth's orbit of the sun that determines our view. From this vantage, it's summer in the northern hemisphere, and towards the pole, the sun may barely set. But in the mid-latitudes, the sky looks like this, with the Milky Way stretching overhead. If you turn your eyes toward the north, these are the constellations you'll see in summer. Near the horizon, you'll find the bright yellow star Capella. Higher up in the Milky Way, you'll find the W-shaped constellation of Cassiopeia. Inside it is an invisible wonder, the radio signature of a star that exploded 300 years ago. Facing south, you'll see the rest of the Milky Way. On the far right, Corona Borealis, the northern crown. Next door, mighty Hercules. And top center, Lyra, the constellation of the heart. Flying along the Milky Way, Cygnus, the swan. Below is tiny Delphinus, the dolphin. Also in the Milky Way is Sagitta, the arrow. Beneath that, Aquila, the eagle. To the left of the Milky Way, you'll find Capricornus, the sea goat. And to the right, Ophiuchus, the snake holder. Further right is the snake itself, Serpens. And lastly, at the bottom, Sagittarius the Archer, with a hint to the right of Scorpius. Turn your binoculars towards Hercules, top right. You'll find M13, a globular cluster of 100,000 stars. In Lyra, top center, is the bright star Vega. Brilliant Vega has a ring of dust, possibly a planetary system in the making. Lower in Lyra is the double star Chauliac. They can't be separated in a small telescope. They're so close they seem to siphon material from one another. Next to them in Lyra is M57, the Ring Nebula. A small telescope highlights a puff left over from a star that exploded hundreds of thousands of years ago. More difficult to spot is the Cygnus Loop, debris from another ancient explosion. But the Hubble Space Telescope shows the shock wave is still racing through space. Here's its position in Cygnus. Shift your binoculars lower in the Milky Way to Sagittarius to see a cosmic showpiece. M27, the Dumbbell Nebula, is the shroud of a slowly dying star. Move on again to Aquila and the bright star Altair, just 16 light-years away. Altair spins so quickly it bulges. If you live further south in the northern hemisphere, in Florida, for example, the summer constellations look like this. Sagittarius is now well clear of the horizon, and beneath you'll find Corona Australis, the southern crown. The whole of Scorpius is visible to the right. Turn your binoculars here above Sagittarius and you'll find M16, a cluster of stars in the Eagle Nebula. 2 million years ago, they formed from the gas and dust that still surround them. This central region of the Milky Way abounds in splendor. We're scanning the vicinity of Antares in Scorpius, a vast nebula, a cloud of dust and gas 5 light-years across. Thousands upon thousands of stars. Towards the galactic center, in this case a picture from Australia. Optically, the view of the center is blocked by dust and gas. Other ways of peering into it present a cosmic conundrum. This radio image suggests a cloud pattern caused by a star-devouring black hole. But the infrared image shows huge stars undisturbed at the galactic center. The heart of our own galaxy remains a mystery.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
In its annual orbit of the Sun, Earth approaches an equinox. It's late September, autumn in the northern hemisphere and spring in the south, the time of the year when days and nights are equal the world over. This is the season to study galaxies. The night sky faces outwards, away from the distractions of our own galactic center. Exotic stars and wondrous clouds adorn the celestial stage. In the southern skies can be seen the Small Magellanic Cloud, a satellite galaxy to our own Milky Way. We know about the nature of stars and galaxies because each one radiates a distinct spectrum of light. In the region of Orion, for example, here are 4 major stars and their spectra: the cosmic fingerprints of Rigel, Sirius, Procyon, and Pollux. Astronomers can compare the spectrum of a star with a laboratory scale. Where the lines match up, certain elements exist. From light years away, we can tell what a star is made of. Spectra can also reveal which way something is moving. Light shifts towards red if a body is retreating, and towards blue if advancing. It's known as the Doppler effect. In the case of galaxies, stars moving toward us have a blue shift. Those moving away from us are red shifted. The autumn sky in the northern hemisphere. First, let's reorient the familiar northern constellations. The Big Dipper, or Ursa Major, is low in the sky. Gemini, the twins. Auriga, the charioteer. Perseus. Cassiopeia, the queen. Cepheus, the king. Hercules, left over from summer. Draco, the dragon. And Ursa Minor. At the center of things, as always, is Polaris. Let's go back down to the 7 bright stars that form part of Ursa Major, also known as the Great Bear, the Big Dipper, and the Plough. One of the 7, Mizar, has a companion, so close it was used as an eyesight test in armies of old. Through a powerful telescope, Mizar is not 2 stars, but 3. The larger companion is Alcor, too far from Mizar to make the pair a true binary, but the smaller one qualifies. We see the sky in 2 dimensions. If we could travel around the 7 brightest stars of the Big Dipper, we'd see that the constellation is an illusion. In 3 dimensions, their distances from each other, as well as from us, are very different, far from the picture they present to Earth. And the stars themselves are moving. In about 100,000 years, the 7 stars will realign to look something like this. If we reverse the process by traveling back in time, they'd form another configuration. The patterns we see today are like a single frame in a movie. The cosmos is ever-changing. This is how the 7 stars would have appeared 100,000 years ago, more like a spear than a dipper. Turn and face south in autumn, and these are the constellations you'll see from the northern hemisphere. Delphinus is still around from summer. The great square of Pegasus, the flying horse. Straggly Andromeda, the chained maiden. The 3 sides of the triangulum. Just beneath, Aries the ram. And the 2 fish of Pisces. Lower down, the sea monster Cetus, sometimes called the whale. To the west, Aquarius the water bearer. And finally, the sea goat Capricornus. Up here in Andromeda, you'll find the most distant object visible to the naked eye. This great galaxy, also called Andromeda. It's a spiral galaxy like our own, with over 300 billion stars, plus a couple of satellite galaxies. The Hubble Space Telescope took a close look at this satellite galaxy, M32, in the early 1990s. From the clarity of Earth orbit, Hubble peered into its heart. Each dot is a star shining like a sun, emitting light that takes well over 2 million years to reach us. Low in the sky, through binoculars, you'll see a faint blur. A big telescope reveals the magnificent Helix Nebula, a cloud of dust and gas expanding at some 25 miles per second, a dying puff of energy from this central star, whose corpse will be a white dwarf. High in the sky, between the Triangulum and Andromeda, the faint galaxy M33. Visible in binoculars, M33 is one of the best full-face spirals in the sky. We're still looking south, but from the lower latitudes of the northern hemisphere. Low in the sky, you'll see the constellation of Piscis Australis, the southern fish. Here is the star Fomalhaut, with an exciting possibility. Recent evidence suggests that it's surrounded by a cloud of cool gas, the kind of cloud that gave rise to the planets of our own solar system. "5 billion years after our own beginnings, a new set of worlds may be taking form. Protoplanets reminiscent of our own Earth and its neighbors. Molten spheres, cooling perhaps, will one day provide a foothold for new life in the universe." The panorama of the night sky holds unexpected wonders and beauties, if you just know where and how to look. Join us for a guided tour through the constellations. Next, on Amazing Space. The sun sinks slowly in the west, or that's the illusion that Earth's rotation creates. Time for the stargazers to emerge and catalog the wheeling panorama revealed by such a spin. A planetarium can link the earthbound to the nighttime heavens. From the Big Bang to the most exotic stars, a planetarium can show you the cosmos in a microcosm. This is a classic planetarium projector, a masterpiece developed by Zeiss in Germany in the early 1920s. It's made up of clusters of small projectors, each throwing pinpoints of light on the planetarium dome, reproducing a segment of the sky. Dubbed the Wonder of Jena after the city of its origin, it's still the source of wonder at most planetariums. As it whirs and rotates, the projector can simulate the celestial movements as seen from anywhere on Earth. To navigate the heavens, modern astronomers divide the sky into a grid. Longitudinal lines are called right ascension, in calibrations of hours, minutes, and seconds. Latitude, or declination, marks degrees north or south of the celestial equator. To match such a grid to the sky, just use your hand. At arm's length from the eye, the little finger and index finger measure off roughly 15 degrees. That's equivalent to 30 moon widths, for the moon, greatly enlarged here, fills about half a degree. The clenched fist equals about 10 degrees. 3 fingers equals 5 degrees. 1 finger approximately 1 degree, or 2 moon widths. To the northern polar sky now. The Milky Way is strung across the northern sky. The pole star Polaris is at the very center, shining bright in the constellation of the Little Bear, Ursa Minor. Next door, Draco, the constellation of the Dragon. Just below, Ursa Major, the Big Dipper or Great Bear. Top center, Cassiopeia, the Queen. To the left, Hercules, a Greek hero. Next to the king, Cepheus. And top right, the constellation of Perseus. Some bright stars. Vega in the constellation of Lyra. Higher up, you'll find Deneb in Cygnus the Swan. And to the right, Capella in Auriga. In long exposure, the trails of these northern stars around their polar axis.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
Here, Earth's orbit takes us into seasonal extremes. The northern hemisphere has the short days and long nights of winter, ideal for stargazing. In the south, it's summer. Looking north, with the Milky Way draped across the winter sky, these are the constellations of the northern hemisphere. In winter, the star Deneb peeps over the horizon, just below Cepheus. If you point your binoculars here, top left, near Perseus, you'll find the brilliant double cluster. 2 groups of stars, some 300 in each, as bright as diamonds. Bottom right, beneath Ursa Major, and best seen through a small telescope, Galaxy M51, with a satellite on its arm. Known as the Whirlpool, M51 has been probed by the Hubble Space Telescope to reveal a strange cross formation at its center, evidence perhaps of a black hole. Turn your binoculars higher up in Ursa Major and you'll find a pair of galaxies. M81 at the bottom and M82, both 8 million light-years away. A view to the north in winter. If you turn and face south, this is your winter sky. One constellation dominates the heavens, the handsome figure of the hunter, Orion. But Orion is just an illusion of the earthbound. If we could fly an enormous circle through space, the stars of Orion would appear quite different in their relative positions. As with all constellations, the familiar patterns are just a matter of our earthly perspective. Orion can guide you through the southern stars. A line through the 3 stars on his belt points to the brightest star in the sky, Sirius. Bright because it's so close to us. Sirius is part of the great dog, Canis Major. The 2 stars at the top of Orion are another indicator. They point to a much smaller constellation aptly named the Little Dog, Canis Minor. Its brightest star is another neighbor of ours, Procyon. Line up these 2 stars in Orion and they'll point you to a great multiple star, the system of Castor. Castor forms the head of one of the mythical twins in the constellation of Gemini. Back to Orion's belt, but instead of scanning towards Sirius, go the other way towards a bright orange star. It's our near neighbor Aldebaran, 40 times the diameter of the Sun. Aldebaran is the great eye of Taurus the Bull. In the shoulder of the bull, a star group called the Pleiades. Orion, our guide to the winter sky of the northern hemisphere. And here's a wider perspective, again looking south. Orion still dominates the picture. The main constellations, with the Milky Way running from Auriga at the top to Canis Major at the bottom. Top right, in Taurus, we take a closer look at the Pleiades, the Seven Sisters. There are far more than 7. Blue, hot, and young, some 250 stars bathe in the dust from which they were born. At the center, still in Taurus, is a tiny pulsar. Spinning 30 times a second, it's the corpse of a giant star that exploded 900 years ago. A supernova that spewed out the Crab Nebula. Top center in Auriga is the double star Capella. Their combined brightness outshines our sun by 160 times. Top left in Gemini, the multiple star Castor, a small red binary orbiting a pair of blue binaries. 6 stars in one, resolving into 3 entities through a telescope. Center left towards Monoceros, you'll find celestial clouds through your binoculars. A black cone of dust seems to point to a central group of stars, the Christmas tree cluster. Also in Monoceros, the beautiful Rosette Nebula, a clutch of baby stars and a nest of hot gas. The brightest can be seen through binoculars. If you could fly towards Orion, you'd meet the star Betelgeuse some 500 light-years out. A red giant that could swallow our inner solar system as far as Mars. This star on Orion's belt, invisible to the naked eye but magnificent through a telescope, is the Horsehead Nebula, a cloud of black dust against a backdrop of red hydrogen. From Orion's belt hangs a sword. Train your binoculars on its tip to view one of the finest objects in the sky, M42, the Great Nebula in Orion, a place where stars are born. Again, if you could fly towards Orion, you'd encounter brilliant Rigel some 900 light-years out, a superstar 50,000 times brighter than the sun, burning so fiercely it'll have a very brief life. But it will end spectacularly in the cosmic convulsions of a supernova, spreading the seeds of new suns to come. Its spectacular shroud announcing the death of a star to the rest of the universe.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
Late March. Our planet approaches an equinox. At this point in Earth's annual circuit of the sun, it's spring in the northern hemisphere and autumn in the south. Day and night are equal around the world. From the seasonal perspective, we're looking out from our own galaxy to those that lie beyond. We look toward the constellation of Virgo and a galactic jet. And in another direction, the celestial enigma of Eta Carina, perhaps a supernova in the making. Objects in the sky are identified by number. This is M100, Messier 100, or in the new general catalog, NGC 4321. In the late 18th century, French comet hunter Charles Messier began numbering unusual objects in the sky. Messier 1 was the Crab Nebula. Messier 31, or M31, is the galaxy of Andromeda. M42, the Orion Nebula. 110 fuzzy objects have a Messier number. Armed with this catalog, we can explore the spring sky. We're in the north, looking north. These are the constellations from the mid-latitudes. Top right in Draco is the star Thuban, once the pole star of the ancient Egyptians. Today, of course, Polaris is the pole star. And in the future, this will be the pole star, brilliant Vega. The succession of pole stars swings roughly within this circle. From Polaris today, the axis of Earth will shift towards Vega, the result of a 26,000-year wobble in the spin of our planet. Towards the horizon near center screen in the constellation of Perseus, the demon star Algol. Algol seems to wink every couple of days. That's because it's an eclipsing binary, dull when one star is in front of the other, bright when they separate. Also in Perseus, it was here in 1901 that a star exploded, a nova. The culprit, a binary with a smaller partner feeding on material from the larger. The result, celestial indigestion and a nuclear convulsion. After another build-up, it will go nova again. Unlike a supernova, the grand finale of a single star. Now we're looking south in spring from the northern hemisphere. Leo, the lion. Bootes, the herdsman. Corona Borealis, the northern crown. Libra, the scales. Corvus, the crow. Hydra, the water snake. And Virgo, the virgin. In Leo, the cross beneath the lion's head seems to spit out meteors, but only in November. It's then that the orbit of Earth passes through a trail of debris left by a comet. The result is a shower of meteors. In Leo's case, they're called the Leonids, but it'll be 1999 before they put on their best display again. The whole region of Leo and Virgo abounds with thousands of galaxies, misty blurs in a small telescope. This one, M87, is a gigantic sphere, probably an amalgamation of several ancient galaxies. The Hubble Space Telescope highlights a great jet shooting out from the galactic center. Scientists think that the jet streams out from a huge black hole. At the same time, material spins into this ultimate gravitational trap. M87 between Leo and Virgo makes for good binocular viewing. Further down, yet another bright galaxy. M104, the Sombrero. Here, through a big telescope, a band of dust girdles the equatorial plane. From Virgo, still lower in the sky, to Corvus. This is the home of the ring-tailed galaxy. In fact, two galaxies in collision. Their immense gravity has strewn great chains of stars across the cosmos. The sights of spring in the north. Now from the southern hemisphere looking north, we see the constellations of autumn. They are largely the inverse patterns of the north. Bottom right in Boöte Arcturus. A giant 25 times the diameter of the sun, the fourth brightest star in the sky and 37 light years from Earth. With the Milky Way straddling the sky, we're now looking south in autumn. The constellations from the southern hemisphere. Top center in the constellation of Carina, the great nebula of Eta Carina. At the very heart of the nebula, the most brilliant star is Eta Carina itself. Last century, Eta Carina was one of the brightest stars in the sky. Today, it seems to be hidden behind a shell of dust, perhaps the precursor to a supernova, the explosive death of a stellar giant. Down to the painter's easel and Beta Pictoris. An interesting star with a disk of dust, here in red and yellow. The star is bright enough for binoculars. Towards the center now, and to the biggest of our two satellite galaxies, the large Magellanic Cloud. Shaped like a bar, it's a mini galaxy with just 1/10 the star population of the Milky Way. In the left-hand side of the cloud is the Tarantula, bright enough for the naked eye. To the right of the nebula, a star blew up and died in 1987. The closest supernova in 300 years. Before it exploded, the doomed star puffed out a ring. Hubble captured it, and this remarkable shot following the explosion. Concentric rings of light race through space from the center of the cataclysm. Upwards now to Crux, the Southern Cross. Here is the Jewel Box, a cluster of brilliant young supergiants. Finally, down a little from the Jewel Box. This is the Coal Sack, not a hole in space, but the best-known dark nebula, and visible to the naked eye. A brief tour of the heavens. A guide that can only hint at the wonders to behold through telescopes, binoculars, or just by looking at the sky. The Sun, our seething parent star, its surface churning with life-giving energy. Join us as we explore this nuclear powerhouse and its rocky little companions. Mercury, next on Amazing Space. Some 5 billion years ago, triggered perhaps by the shock waves of an exploding star, a whirling cloud of dust and gas begins a slow inward spiral. Within that cloud, all the raw materials that will become the sun and planets. As the cloud condenses, its central gravity increases. The vast aggregation collapses in on itself. The dense center grows intensely hot, and nuclear reactions ignite at the core. An embryonic sun flares into life. Meanwhile, throughout the rest of the cloud, great swirls of material begin to shape the 9 planets of the system. 5 billion years later, our sun moves gracefully into middle age, just one of the 100 million stars in our galaxy. Compared to Earth, the sun is gigantic. It's more than 100 times wider than Earth, and 1,000,000 times more massive. Even sunspots are several times bigger than Earth. By analyzing the light it radiates, we've discovered much about our sun. It's made of 3/4 hydrogen and 1/4 helium. It rotates every 27 days. Surface temperature, 10,000 degrees Fahrenheit. At its center, nuclear fusion turns 4 million tons of hydrogen into helium each second. Core temperature, 30 million degrees Fahrenheit. The energy produced here takes eons to reach the surface. When seen in soft X-rays, the sun's image takes on another dimension. The small picture shows the same sequence in visible light. X-rays reveal the hectic energy of the sunspots. Sunspots probably mark places where intense lines of magnetic force shoot through the surface, tangled and distorted by the sun's rotation and by its churning surface, the yellow photosphere. They show up as dark areas amidst the bright churning photosphere. The heat bubbles in those brighter areas measure some 500 miles across. The sunspot appears dark because it's 3,600 degrees cooler than the surrounding area. The center is called the umbra, its edge, the penumbra. Sunspots often appear in groups, taking up to 10 days to form and about 2 weeks to fade. During quiet periods, the sun may have no spots at all. These sunspots were filmed in 2 different kinds of light. Here, in visible light. Here, in the red light emitted by hydrogen. Both show huge arcs bent around magnetic force lines. Gigantic billows of hot gas, like this whale fin, arch into space from the surface of the sun. They're called prominences. When silhouetted against the sea of firestorms that make up the bubbling photosphere, they appear as dark ribbons called filaments. Prominences can extend hundreds of thousands of miles into space and persist for weeks, suspended in magnetic arcs. But the most spectacular phenomena are flares, eruptions with the energy of 10 billion megaton bombs. Bottom left. Shockwaves radiate from an exploding flare, rippling through the sun's gaseous surface. Project stupendous quantities of material at millions of miles per hour, hurling energized particles out from the sun as part of the solar wind. On Earth, these particles can disrupt telecommunications. Fortunately, most are deflected by the Earth's magnetic field, except at the poles. There, as the charged particles fall earthwards, they glow. The the Northern Lights, bright ethereal reminders of our intimate connection with the sun.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
The interstellar cloud that formed the solar system spawned 9 companions for the newborn sun. As the heat of the sun increased, the high-energy particles streaming from it drove lighter elements outwards. These lighter materials formed the gas giants, like Jupiter and Saturn. Heavier elements nearer the sun condensed into the smaller inner planets. Bombarded by meteors, they took shape: Mercury, Venus, Earth, and Mars. Today, bathed in warmth and sunlight, they're solid little planets with hard-baked crusts. When seen from Earth, the 2 planets closest to the sun hug the horizon. Because Mercury and Venus are so close to the sun, they're best seen at dusk or dawn. Mercury on the right barely clears the skyline. Venus takes 224 days to orbit the sun. Little Mercury just 88. Mercury never strays more than 43 million miles from the sun and is perpetually scorched and irradiated. Pictures from Mariner 10, a space probe sent to Mercury in the early 70s, reveal barren and a world of extremes, temperature by day, cracked and battered little planet. The craters testify to the sun's immense gravity. Space debris plummets inward, and nearby Mercury is in the line of fire. Mercury's surface is like the hidden side of our moon. Both have great circular basins, and Mercury isn't much bigger than the moon. Venus, the next planet out, presents quite a different face. It's almost Earth's twin in size and density, but completely veiled in swirling clouds. What lay beneath that veil remained a mystery until a Soviet probe penetrated the Venusian fog, a probe designed to withstand nightmarish conditions. It was a descent into hell. Atmosphere 90 times heavier than the Earth, hot enough to melt lead. Visibility, just 2 miles. To Earth, the camera halted. Radar provided a better picture. Orbiting mappers electronically stripped the clouds to give the first wide-angle images of Venus and confirmed the volcanic landscape hinted at by the Soviet. Venus turned out to be flatter than expected. There were few craters and less contour than on Earth or Mercury. It looked like the bottom of an ocean, smoothed by the motion of currents. More delights. The globe stripped of cloud in its reverse rotation to all of the other planets. And through the wizardry of computers, radar let us buzz the Venusian surface. This is the topography of Venus, our flight meticulously rendered from radar images. The simulation exaggerates heights and guesses at color, but otherwise, the features are accurate. This flight was made possible by nipping and fractures, a sinuous channel, possibly a lava flow. Fold mountains called Freya. A corona, possibly a collapsed volcanic crater. Cleopatra, a double-ring crater. The Etna Range with an asteroid crater. And flattened volcanic extrusions like mushrooms. Volcanoes everywhere, but so far no signs of activity. Venus is the most volcanized planet in the solar system. Magellan discovered linear mountain belts, a feature shared only with Earth. But the scarcity of impact craters compared to Mercury suggests a young landscape and a surface shielded from bombardment. All but the biggest cosmic missiles would vaporize in the dense sulfuric soup of Venus's atmosphere. The pressure of that atmosphere weighs heavily on the surface. Volcanic eruptions seem squashed into pancakes. Such formations can be found at the bottoms of our seas here on Earth. But Magellan's images cannot convey the hell of Venus. A crushing, poisonous atmosphere of carbon dioxide with clouds of sulfuric acid, boilingly hot. This is the more likely scene, an inferno where light bends and heat cannot escape. The ultimate greenhouse effect, plus non-stop thunderclaps. Venus resembles a little understood period on Earth, from just after Earth's crust had cooled to the emergence of life. Why Venus never emerged from its hellish state is a mystery.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
Planet. It scans familiar terrain. Mars' bottom center is the fourth planet. Its trip around the sun takes almost 2 Earth years. Mars has much in common with its neighbor Earth, despite its smaller size, weaker gravity, and thinner atmosphere. Like Earth, Mars has polar caps, distinct seasons, and a tilted axis. Probes sent to Mars have captured pristine images, no thick atmosphere like that on Venus to block the view. From Earth, the northern cap can be seen by telescope. In summer, the cap recedes as winter grips the southern pole. This southern cap is mostly frozen carbon dioxide. The northern water ice pulls outwards. The Mars is peppered with them. Solar system. Now, with data compiled from the Viking probes of the 70s, we can swoop down on the red desert of Mars. First, a glide over Mariner Valley, the planet's most extraordinary feature. A rift that would stretch from sea to shining sea across North America. We can see faint clouds below as we position for a swing over the 3 giant volcanoes of the Tharsis Ridge. Martian cloud, like Earth's, is water vapor, but there's less of it. Overnight frost, burned off by morning sunshine, forms mist in the canyons. Further out than Earth, Mars is a chilly place. But midsummer temperatures at the equator can reach a comfortable 75 degrees Fahrenheit. A low-level turn for a buzz down Mariner Valley. And there's Arcea, the southernmost of the Tharsis triad. Pavonis. And Ascraeus. 3 gigantic shield volcanoes like those that rumbled from the depths of the Pacific to form the Hawaiian Islands. Mars has 2 little moons, Phobos and Deimos, named after the mythical sons of Mars, Fear and Terror. Both plan to explore Phobos. A craft dropped probes on the surface. Sadly, just as their work was about to start, a Martian dawn in 1976. Within weeks of each other, Vikings 1 and 2 had soft landed on the surface. This is what they found. A lifeless desert, rusted red by iron oxide. Midday temperature minus 20 degrees Fahrenheit. Atmosphere, carbon dioxide. 150 times thinner than Earth's. What they didn't see, the great dust storms that blow up periodically on Mars. These storms can envelop the entire globe, as filmed from here on Earth. But the Martian climate hasn't always been so bleak, as these river-like channels testify. This teardrop also hints of flowing water. Scientists think Mars once had an atmosphere as dense as Earth's, with clouds from which rain fell freely. So where did the water go? One scenario implicates the weak Martian gravity, which let the atmosphere leak into space. At first, any air lost this way would have been replaced by belching volcanoes. But when the eruption ceased, Mars was in trouble. Its protective blanket of water vapor and carbon dioxide disappeared, and the red planet became a chilly desert, seemingly devoid of warmth and water. But future missions may find water after all. Some think it lies frozen beneath the surface. And mobile robots will search for signs of life. The chances are slim, but some biologists still hold out hope that single-celled creatures may lie dormant in the red soil of Mars. Samples will be collected and dispatched to Earth for analysis. But it is to Mars we must go if we are to set our sights on the other planets or the stars. A planet wrapped in a dynamic web of life. The moon, its barren but inspiring companion. And the brilliant intruders that streak across our skies. Join us as we explore our own corner of the universe. Next on Amazing Space. The spacecraft Galileo hurtles by Earth. Its final destination, Jupiter. On its way, it captures the first images of planet Earth in rotation. The sun's reflection skims across the Pacific towards Australia. A compilation of cloudless satellite pictures shows the blue planet as never before. the ideal incubator for life. Now we see the upper atmosphere, the gaseous shield of the ozone layer, here in motion. It's this filter that protects us from solar radiation, that allowed life to take root on Earth. Over eons, plants have changed our atmosphere by breathing oxygen into it. Today, CFC emissions may be changing things again, starting with this hole in the ozone at the South Pole. Earth has a busy, sometimes violent atmosphere, made up mostly of nitrogen and about 20% oxygen. Though we may tamper with it, Earth's atmosphere in turn can unleash a fury that reminds us of who's really in charge. Some forces of nature are still beyond us. Wind systems are driven by hot air rising at the equator, twisted by the Earth's spin. That same spin gives us our daily mirage, the sun moving westward across the sky. In fact, the sun is relatively still. It's our planet that's moving, a 24-hour rotation that creates day and night. Time-lapse photography shows the moon, top left, sinking in the west. And here, the Milky Way and the stars seem to travel through the heavens. Again, it's not the stars that are moving. It's the Earth, rotating on its axis, that creates this turning panorama. Were Earth straightened up, day and night would be equal the world over. But the 23-degree tilt from vertical varies the length of night and day. As the tilted Earth orbits the sun, we get our seasons, defined by which part of the Earth is getting the better half of the sun and when. Here, summertime in the northern hemisphere. Satellite pictures reveal the changing seasons in Europe. They document the spread of vegetation growth as the northern hemisphere tilts toward the sun, bringing spring and then summer. In Antarctica, we can see the seasonal ebb and flow of the ice cap. "71% of the Earth's surface is ocean. The solid remainder began as one giant landmass some 250 million years ago. Ever since, its pieces have drifted towards their more familiar positions on plates that ride the Earth's molten mantle. These dots represent volcanoes, geologic hotspots that mark cracks in the Earth's surface where the continental plates meet. Even today, the drifting continues. This lava lake is like plates parting, and this like plates meeting and subducting. Where plates interact, volcanoes erupt. The Mount St. Helens volcano sits on the dividing line between the Pacific and North American plates. A sobering reminder of Earth's volatile interior. From high above the clouds, the signature of another eruption, Mount Pinatubo in the Philippines. Stratospheric pollution that reduced Earth's temperature by a degree as volcanic ash girdled the globe. Before Pinatubo, a sunset with stars. Afterwards, a red haze of volcanic dust. Here, a very different kind of pollution. The bright lights of civilization that obscure our view of the stars. In the future, the view from Earth will depend more on human factors than geological ones.
Amazing Space will return on TLC. Amazing on TLC.
These are the first pictures of Earth and Moon moving together in space. Here, close-ups of the Moon's lava fields, colored in ways that highlight a contrasting landscape. The spacecraft Galileo captured these astounding images while testing its equipment before slingshotting towards Jupiter. Galileo sailed over the lunar North Pole, a region difficult to see from Earth. Like much of the Moon's surface, the pole is scarred by craters, most blasted out by meteors in the hectic heydays of a newly formed solar system, some 4.5 billion years ago. Despite the lack of air, the Moon is ripe for colonization. In the 21st century, we may set about building lunar bases, self-sufficient stations that wring oxygen from lunar rock. Pioneers will explore the Moon for raw materials, conduct radio astronomy, free from static on Earth. The Moon from Earth's point of view. These are the scans through a telescope, like the view from an orbiting satellite. Here, a huge crater, and mountain ranges like those on the planet Mercury. The bright highlands peppered with craters. Moon watchers once thought these were oceans, dark seas covering 15% of the surface. We now know they're impact scars filled and smoothed over by ancient lava. From 240,000 miles away on Earth, the crater Copernicus. A vantage point over the poles reveals the source of the Moon's familiar phases. As it orbits Earth, catching different angles of sunlight, it waxes and wanes to an Earth-bound observer. Again, with a central frame showing the Moon phases we see on Earth. The Moon rotates as quickly as it revolves, and always shows the same face to Earth. Only if the Moon stopped in its orbit would its rotation be apparent. Compared to Earth, the Moon is rather small. It would fit across North America. Earth is about 4 times wider across than the Moon. Some 240,000 miles separate us. 30 Earths would bridge the gap. The Moon is close enough to influence things on Earth. Some would say it gives rise to lunacy, but we know for a fact that it gives rise to tides. The Moon's gravity tugs at our oceans. Add that to the Moon's orbit and Earth's rotation, and the seas move with an ebb and flow that can leave a lighthouse stranded on an island. About once a year, the Moon falls under the shadow of Earth, producing a lunar eclipse. The Earth's dusty atmosphere bends sunlight back on the Moon, bathing it in a red glow. Although a total solar eclipse lasts just minutes, a lunar eclipse can last hours. The Moon is 400 times nearer to Earth than the Sun, which creates an astonishing effect during the Moon is also 400 times smaller than the Sun. This means that it can fit perfectly over the Sun's disk, producing a total solar eclipse. This familiar sight has inspired the imaginations of men and women throughout the ages, fueling myth and metaphor. But can science tell us where it came from? Could it have come from Earth? When Earth was very young, it may have been struck by a smaller would-be planet and blew both apart. As Earth reformed, lighter material fell into orbit around it and shaped a moon. Slowly, it cooled. Its crust solidified. But over eons, cosmic debris bombarded the moon. Great basins were left, filling with molten rock from the interior. These hardened to shape the familiar moonscape that has so long.
Amazing Space will return on TLC. Continues on TLC.
Within the clockwork precision of our planetary system, there are rogues, things with strange and varied orbits that defy our orderly image of the cosmos. Some plunge directly into the sun. Others just miss. Comets and their cousins, asteroids, are the wild cards of the planetary pack. This is amateur video of cosmic debris falling to Earth as a fireball. Such flotsam from space may have doomed the dinosaurs. A 6-mile-wide asteroid may have struck Earth, raising a cloud of dust that shut out the sun and ushering in a prolonged winter. Along with most other living creatures, the dinosaurs perished. Comets come from the Oort cloud, a halo of debris beyond the farthest planets, drawn in by the sun's gravity. A comet is a dirty snowball, icy space junk left over from the formation of the solar system. But as it nears the sun, it undergoes an incredible metamorphosis. It begins to effervesce. The sun's heat vaporizes part of the comet. Gas and dust stream off as a tail of plasma. By now, the comet is in close solar orbit, its glowing tail blown backwards by the solar wind. The comet sports this classic shape only when it's close to the sun. Farther out, the tail disappears. A photograph shows its features. The nucleus is shrouded in a dense cloud called the coma. There are yellow tails of dust and a straighter tail of ionized gas, fluorescing blue over millions of miles. The most celebrated comet is this one, Halley. Comet Halley carves a huge ellipse through the solar system every 76 years. From its farthest point beyond Neptune, Halley hurtles toward the inner planets. The comet last rounded the sun in 1986. It was Halley's first appearance in the age of spaceflight. The European probe Giotto went to get a closer look and took a plunge into Halley's coma. These are Giotto's pictures. At the center, the nucleus measured about 5 by 9 miles. Each second, it spewed 20 tons of gas and 10 tons of dust. Battered by debris from the coma, Giotto flew within 350 miles of the nucleus. From Earth, this is our best picture. But as Halley receded, its image faded. Then in 1990, it brightened. Scientists think the comet may have been struck by an asteroid, or there'd been some sort of explosion. Each time it swings past the sun, a comet leaves a trail of debris. Sometimes Earth blunders through that trail, and the result is shooting stars. These are showers of cometary dust burning up in the atmosphere. Most are periodic and predictable, lighting up as our orbit crosses the trail of known comets. Earth is continually bombarded by tiny meteors. They streak in at up to 150,000 miles per hour and vaporize high overhead. Sometimes they're bigger. Lumps of planetary debris the size of a fist or larger can survive a journey all the way to the surface. They descend as fireballs. One hits Earth every 2 hours. A man videotaping his office in 1992 captured this fireball in the sky over Pittsburgh. Part of it hit a car in New York. This is a typical stony meteorite. Its dark crust formed as atmospheric friction melted its surface. The friction of air also gouged thumbprints on this iron meteorite. This one may have been cracked off our moon in some ancient impact. And this may be from Mars. Beyond the orbit of Mars are the asteroids, a vast belt of debris formed, or perhaps from a collision of young planets. Heading toward Jupiter, the space probe Galileo caught a close-up of an asteroid in 1991. This strangely shaped lump named Gaspra was 10 miles long. It was our closest encounter ever with an asteroid. Pocked and battered, Gaspra was rich in metal, unlike the lighter Martian moons Phobos and Deimos, themselves thought to be captured asteroids. A 1992 picture of something orbiting beyond Pluto. A 10th planet? No, just a 200-mile-wide ice block. This is Chiron, another asteroid-like body, but with a comet-like coma, here in blue. A piece of evidence suggesting that comets and asteroids are somehow related. Radar images of asteroid Castalia show what may be two bodies in close embrace. And this is Tutatis, which in 1992 came within 2.5 million miles of Earth. The occasional major impact is inevitable. The results can be catastrophic. Like the Manicouagan crater in Quebec, a gigantic impact from 200 million years ago. And Goss's Bluff in Australia, now well eroded. Australia's Wolf's Creek crater, 60,000 years old. This relatively small one in Arizona was blasted out just 25,000 years ago. It will happen again. And what's this in the heart of Europe? It's still just theory, but some think these computerized satellite images may reveal an enormous distorted impact crater lying between the Alps and the Baltic, a harbinger, perhaps, of things to come. Giant Jupiter, glorious Saturn, tilted Uranus, and distant Neptune. Join us as we follow the intrepid Voyager probes next on Amazing Space. Voyager, an unlikely-looking candidate for the most successful spacecraft ever. In 1977, NASA launched Voyagers 1 and 2 towards the mysterious giants of the solar system, the outer planets. 2 years later, the first target filled their sights, Jupiter, with 1,000 electric storms flashing in its clouds. The Voyagers found massive belts of weather, unlike anything ever seen before in turbulence. This hole in the cloud deck, the dazzling red spot of Jupiter, a storm system 3 times the size of Earth, 100 years old. As Voyager approached the planet, a portrait of a colossus emerged. Circled by moons as big as planets, trailing their shadows across its immense surface. Jupiter's size overwhelms the mind and the eye. Bigger than 1,000 Earths, bigger than all the other planets put together. Had Jupiter been just 10 times its size, it would have been a star, our solar system a binary one. But its nuclear furnace never ignited. At its center, Jupiter may harbor a tiny solid core set in pressurized ice. But otherwise, it's a huge ball of gas, hydrogen, methane, and ammonia, rotating every 10 hours. Immense Jupiter gives off more heat than it receives from the sun. The combination of heat and spin generates astounding weather bands, circulating at different speeds and directions, and creating wonders like the red spot. It's an anticyclone, a monstrous area of high pressure. When seen in infrared on the right, the source of Jupiter's tempest stands out. Hot gas driven up from the interior glows red. Colder descending gas is white and pale blue. Voyager discovered that Jupiter has rings, fine powdery remains of a pulverized Jupiter circle the Earth. Voyager's pictures of Ganymede catalog the largest moon in the solar system, bigger than Mercury or Pluto. Had Jupiter managed to become a star, Ganymede would have been a planet and a much warmer place. At -300 degrees Fahrenheit, the surface is an icy crust. Wrinkles and craters, an old and unchanged topography. Beneath the crust, a mantle of slushy water riding on a rocky core. Voyager also scanned Callisto. The probe's next encounter captured an altogether different landscape. The moon, as the others, had been rough, planet-sized ocean. If there's life to be found in the solar system, it probably resides here, in the seas of this moon. Io, the innermost of the 4 big moons of Jupiter, held a surprise for Voyager 1. Volcanic plumes. Caught in the act, amidst a sulfurous landscape, and a lake of liquid sulfur. Voyager 2 took a closer look, profiling the most active volcanic body in the solar system. Caught in the gravitational tug-of-war between Jupiter and Europa, Io erupts continuously. Its troubled surface, a crust of sulfur floating on a sulfurous ocean, is smudged with black volcanoes. Io has the only volcanoes seen in eruption, other than on Earth. Their Julian mission accomplished, the Voyagers set off on the long next leg of the journey. Another splendid giant in their sights, Saturn.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
Of all the planets, Saturn is perhaps the most beautiful. The spectacularly haloed planet is second in size only to Jupiter. Compared to Earth, a monolith. 75,000 miles across. And like Jupiter, it's a giant ball of gas. If you could find a container big enough, you could float Saturn in water. Years, and almost 900 million miles from home, the Voyagers approach the Saturnian system. Titan. With Saturn barely visible through the haze, the view from Titan might look like this. An atmosphere rich in nitrogen, like Earth's, but denser. Lakes and seas on a moon bigger than the planet Mercury. Titan could be the Earth in deep freeze. After radioing home the Titan data, Voyager performed a course correction for Saturn. And this is what it saw on the long approach. Saturn. Its famous rings and its moons. Like its bigger cousin, Jupiter, Saturn may have a tiny solid core, but the rest is gas, mostly hydrogen, some helium. Unlike Jupiter, however, Saturn cloaks its weather beneath blurring smog. But a change in filter reveals the same frantic weather bands. And track them. Top right, just discernible through the smog, Europe appeared. On Saturn, though, they blow at 900 miles per hour, faster than the speed of sound. Voyager 2 headed 100 miles in diameter. Computers allow us to explore its icy, rocky surface. Here's the view from Mimas, another rocky snowball. Tiny also, but bearing an impact scar the size of Mount Everest. Other moons of Saturn may not have been as lucky. The planet's spectacular rings probably resulted from such cosmic collisions. Their contents, lunar debris. With the help of an obliging background star, Voyager surveyed the rings. But they were less than a mile thick, and there are thousands of them. The dark spokes revealed in these time-lapse photos may be dust, levitated above the rings by Saturn's magnetic field. What centuries of speculation are spotted. Astronomer Chris found 7 main bands of rings. Seen edge on, the gaps between the main bands of rings stand out clearly. Shepherded by little moonlets, the particles in the rings range in size from specks of dust to icy rocks as large as cars. After surveying the glories of Saturn and its delicate rings, the Voyagers would part company. Voyager 1 headed up and out of the solar system. Voyager...
Amazing Space will return on TLC. Amazing Space now continues on TLC.
Uranus, seventh planet from the Sun, broods in the dark outer regions of our solar system. Its axis strangely tilted, 1 3/4 billion miles from the Sun. Until 1986, we knew virtually nothing of Uranus. From Earth, this was all we could see. Then outward from Saturn came Voyager 2. Now so distant, we had to build bigger antennae here on Earth to keep in touch with it. With its twin, Voyager 1, heading away from the planets, Voyager 2 ripped to Uranus. The first photo failed to penetrate the fog, but the probe did detect some atmospheric turbulence. Besides the wildly tilted axis of rotation, Voyager also found an out-of-kilter magnetic field tilted 60 degrees from the spin axis. Voyager counted 11 rings and found them to be wider across than Earth. Uranus itself, another gas ball with a tiny rocky core, is the third largest planet in the solar system. And as expected, Voyager spotted unknown Uranian moons, 10 more than were known, bringing the total to 15. The outer little Miranda stole the show. It is Bill's emotional tug, or even some cosmic the moon apart. Voyager also scrutinized the rings of Uranus, or an even larger cosmic collision. Uranus may have been knocked sideways by a spectacular crash with an Earth-sized body. Voyager took 4 more years to reach Neptune and was now 12 years from home. The view from Earth. Like Uranus, Neptune displayed a magnetic field out of sync with its rotation, tilted some 47 degrees. The planet rotated every 16 hours. Compared to Earth, Neptune is a giant, but it's slightly smaller than neighboring Uranus. Neptune upwards from the eye, the great dark spot every 18 hours. A tempest as big as Earth. Before they turned out to be clumps. Its atmosphere hydrogen, helium, and a touch of methane. Methane absorbs red light, giving for its last mission to Neptune's biggest moon, Triton. Voyager, moving at immense speed past the moon, fired maneuvering jets to align for sharp photography. The probe beheld a strange world in its last frozen eruptions. Nitrogen, a retrograde orbit. And strangest of all, with its trail emphasized in black, a geyser of nitrogen. Triton probably once orbited the Sun, but passing too close to Neptune, it was captured. Out here, with the Sun almost 3 billion miles distant, Voyager's work was finished. It would leave Pluto at the solar system's edge unexplored. Seen through a telescope on Earth, Pluto is just a blur. Through the Hubble Space Telescope, it divides in two. Pluto has a moon, Charon, that's half the size of the planet. They are tiny frontier worlds that for the time being we can only guess at. Far from the paths of the Voyager probes as they plunge into the galactic depths. A job well done.
The moon landing